Welcome to my Kcse Mathematics Revision channel. Teacher James Marita. We are looking at the past Kcse questions on differentiation, and today we are looking at a question of Kcse 2015 section P that was carrying 10 marks. In Kcse 2015, there was this question whereby the candidates were given the question of a curve as y is equals to p2 x raised to power 3 minus 9x squared plus px, we have this px minus 1. So the value of x was equivalent to 4 and the gradient of that curve was equivalent to 36 at that point. So we are supposed to find the value of, the value of p. Since we have been given, understand this term gradient. So once we have been given this term gradient here, it means we are supposed to find change in y, change in x. So change in y, change in x is our gradient. So it means we can say that our dy all over dx, which is our gradient, is equivalent to, you take 2 times 3, which is giving us 6x. Then this power here, which is 3, you reduce by 1, this one remains as x squared. You do the same, you minus 2 times 9 is giving us 18, then we have x. 2 minus 1 remains 1, so this one remains like that. Then plus p here, the power of x here is 1. 1 times p is equivalent to p. 1 minus 1 is equivalent to 0. And you understand from form 2, any number to power 0 is equivalent to 1. So it remains like that one. But the gradient of this one here is given at 6, and the value of x is equivalent to 4. So we can be using these two things here, whereby we have the value of x which is equivalent to 4, and that gradient which is here now, dy dx, the value of dy dx is equivalent to b, that's 6. So from here we can substitute here 6 into the value of x, which is 4. This one is squared, minus 18, the value of x here is 4, then plus p. And therefore this one is giving us dy dx, but the value of dy dx is equivalent to p, that is 6. So from there you can go ahead and get the value of p. So substitution of this side will give us 24. So we have this is 24, then plus p is equals to p, 36. So the value of p is equals to p. It is 36 minus 24, and therefore the value of p is equivalent to 12. So that is it. So part P, the equation of attachment, we are supposed to get the equation of attachment to the curve. But let us write this equation first. Since we have now the value of p, we can write that the equation of the curve. The equation of a curve, since now we have the value of p, is y is equals to p2 x raised to power 3 minus 9x squared plus the value of p is now 12. So we have this is 12, and then we have that x, then minus 1. That is now becomes the equation of the equation of a curve. So we have been told we are supposed to find the equation of a curve at where the value of x is equivalent to 0.5. So getting an equation of a curve, you need to get the gradient of a curve. After getting the gradient of a curve, then you get the points where the points at where the tangent and that curve. So from here, from this equation here, and we have the value of x is equals to p5, we can get the coordinates of that tangent. So the coordinates of a tangent we can substitute here. Y is equals to p2, then we have x is 0.5, so we have this is 0.5, you raise to power 3 minus, this is 9, then we have 0.5, this is a square there, then plus 12, this is 0.5, and then minus 1. You will get that value of y as 4.5. So you get this value of y as 4.5. So we have now the points. The point of that tangent, it passes through x is equals to be 0.5 and y is equals to be 4.5. Then we go ahead and then we get the gradient of a curve. We have a derivative of this. The derivative of the gradient derivative of that, which is dy all over. We have been given that gradient dy dx is equals to be dy dx is equals to be dy dx is equals to be. We are supposed to get the value of x. So we have dy, then we have dx, which was equivalent to p. This one is 6. Then we have x squared minus 18. Then plus the value of p is equivalent to 12. So from here we can substitute. Since we have the value of x as 0.5, that gradient ni ngapi? Tunaweka hapa 6 into 0.5. This one is squared minus, this was 18x. There is 18x here. So we have 18 into the value of x, which is 0.5. So we have 0.5, then plus 12. And that one will give us a gradient of 4.5. A gradient of 4.5. I want to do a correction here. When you substitute here, the value of x is not 4.5, but the value of x here, the value of y there is equivalent to be 3. Make a correction here. Because we have, if we substitute the value of x as y is equals to be this one here, y x is equals to be 0.5, and then we substitute here 2 into 0.5, the answer here is 3, not 4.5. So we get that gradient as 4.5. So the points here now will change. It's not 0.5, but 0.5, 0.5, that's the point of the curve. So the points now we have a point which is 0.5, 3. We have that gradient, we call it the gradient 1, which is equals to be 4.5. And then we have an imaginary coordinates in terms of x, and so we have this one in terms of x and y. So how do you get the equation of that tangent changing y? So we have y minus 3 here, then you divide it by, then we have this is x minus 0.5. X minus 0.5, it will give us a gradient, and our gradient here is equivalent to be 4.5. You can simplify that equation, and then you get in a form of a linear form that y is equals to be 4.5x, then plus 4.5x plus 0.75 in linear form. That is how you can get the equation of that curve. So equation of a curve, step 1. Since we have we were supposed to find the value of x, p as x, p as 12. So you write the equation of a curve. Equation of a curve, now after getting the value of p, it will be 2x raised to power 3 minus 9x squared plus 12. 12, this one now here is the value of p, 10 minus 1. Then you are supposed to get now the points of the tangent, the point of the tangent and that curve. So you substitute where x is equals to be 0.5. You substitute in this equation here, you get that the value of y is equals to be 3. Then that one gives us the coordinates of the tangent and the curve as 0.5, 3. Then we have the gradient. Gradient yetu ilikuwa ngapi? Gradient ni 6x squared minus 18x plus 12. 12 was the value of b. Then from there we have been told the value of x here is equals to be 0.5. When the value of x is equals to be 0.5, what is that gradient? You also substitute 0.5 here, you get that gradient is equals to be 4.5. You go back to the form 1, form 2 work, where the equation of a line, how to get the equation of a line, the gradient of a line, it is changing y coordinates or a change in x coordinates. And that one now in linear form, you will get that the equation of that curve, the equation of that tangent is equals to be 4.5x plus 0.75. Then the part 3 we are supposed to find the coordinates of the turning point of the curve. The coordinates of the turning point of the curve, understand here, that the gradient function is equivalent to 0. So here we say that our dy, so we have the gradient function which is dy dx is equivalent to 0. And then we have this dy dx. What is it? Our dy dx is here. So we have a 6x squared, which is our dy dx, minus 18 of x plus 12. This one is giving us 0. So from here, we form a quadratic equation. In that quadratic equation, there are 3 formulas of solving a quadratic equation. You either use a complete square method to get the value of x, or you can use the Kcse formula, that is the product sum and factor method, or you can use the quadratic formula to get the value of x. But here now you can, if you are using the quadratic formula, you can simplify this one here, because 6 can divide here. You can reduce this one by 6, such that we have now this equation as x squared, then minus 3x plus 4 is equals to 0. So if you decide to use the quadratic formula, you can quadratic formula normally says that x is equals to p minus p plus or minus. We have a square root. This one is p squared minus 4ac. Then you divide by 2 multiplied by a. From this equation here, the coefficient of x is equals to p1. It means that the value of a is equals to p1. P is equals to negative 3. P is equals to negative 3. The value of c is equals to p4. So you substitute there and then you get that x is equals to p. The p here is a negative 3 and there is a negative. Negative and a negative is positive. So we have positive 3 there, plus or minus a square root. Negative 3 squared is giving us 9. Then we have minus 4. This is 4 times a. A is equivalent to 1 times c. C is equivalent to 4. Then you divide by 2 times a. It is 2 times 1, which is giving us, that one is giving us 2. Correct substitution from your calculator, you will get that the value of x either is equals to 2 or x is equals to p1. So correct substitution, x is equals to p2, or you get that x is equals to p1. So from our quadratic equation here, we find that the values of x is equals to 2 or x is equals to p1. This one is not giving us the coordinates of the turning points of the curve. Where there is x is equals to p2, what is the value of y in this equation here? In this equation here, what is the value of y? When x is equals to p1, what is the value of y? That one will give us the coordinates of the turning point. So we can proceed. When x is equals to p2, we come back here in our equation here, where the value of y is equals to p2 into bracket. This one is 2. We substitute here by 2 raised to power 3 minus 9. Then this is 2, which is a square. Then plus 12 times 2, then minus 1. So when you substitute, if you substitute there, you get that the value of y is equivalent to p3. So you get the first turning point of that, the value of x is equals to p2, and the value of y is equals to p3. So the first turning point of the curve is 2, 3. The second turning point of the curve is at the x is equals to p1. When x is equals to p1, what is the value of y? So y is equals to p. It is 2 into bracket 1 raised to power 3, then minus 9 into 1. This one is squared, then plus this is 12 into 1 minus 1. So if you substitute that one, you get that the value of y is equals to p4. So the second turning point of the curve is y is equals to p1, x is equals to p1, y is equivalent to p4. So this is the second turning point of the curve, and that is the first turning point of the curve. Remember, when you look at the turning point of the curve, it is the same as when the particle is at the particle is at rest, when the particle is at the highest point, when the particle is at the minimum point. So that's what we are talking about, the turning point of the curve. It might be done at the highest point, or it might be done at the lowest point. You understand that at that point, the gradient function is equivalent to 0, and at that point, you need to form a quadratic equation where you can use the three methods to find the value of x. After getting the two values of x, you go back to the equation of the curve, you substitute the values of x there, they will give you the values of y, and that one will give you the coordinates of the turning points of the curve. Don't forget to subscribe to my channel, watch and share.